F is Riemann integral on closed interval AC and F is Riemann integral on another closed interval CB, where C is lying between A and B, then F is Riemann integral on closed interval AB, and integral A to B f of d alpha is equal to integral A to C f d alpha plus integral A C to B f of d alpha. Right? So breaking in C. Yes. The proof is, let P be any partition of closed interval AB such that C is the element of P. C is belonging to P, right? So let me take P1 to be equal to P intersection closed interval AC, and taking the another partition P2 is equal to P intersection closed interval CB. If you look at this figure, this is your closed interval A to B and this is your point C. So up to x0 to C is my P1 and from C to xn is P2. So P1 and P2 are the partitions of closed interval this AC and CB respectively, right? Where P is of course the union of P1 and P2. Now starting with the summation part, taking S of P f alpha, which is equal to this summation closed interval AB f of Ti into delta alpha I, where this Ti is belonging to xi minus 1 xi. Okay, why I have taken here the closed interval AB? Because I need to split the interval into two. So this is equal to summation, okay, first interval from A to C, f of Ti delta alpha I, and then the summation on the second interval from C to B, f of Ti delta alpha I. Fine. So this is equal to, according to the definition, this is equal to sum P1 f alpha, because this interval is for P1, plus this is SP2 f alpha. Right? Now, since f is Riemann integral, this is given to us on closed interval AC and f is also Riemann integral on closed interval CB. So for given epsilon positive, we need two partitions. Let's say P1 dash, which is a subset of P1 of closed interval AC, and let me take P2 dash, which is the subset of P2 of closed interval CB, such that, so taking the mod of SP1 f alpha minus A to B f of d alpha, this is less than epsilon by 2. Oh, I'm very sorry, this should be from A to C, right, for P1 partition, and SP2 f alpha minus from C to B f of d alpha. This is strictly less than epsilon by 2. Now, P1 dash union P2 dash. This is also a partition of closed interval AB, right? Such that P1 dash union P2 dash is also the subset of P. And we have, okay, what is required to prove? This is your A. So subtracting this A from SPF alpha and taking the mod, right? From here you have to continue. So this is equal to mod of S. Okay, this is for P1 f alpha because it is a union of P1 and P2. This P is a union of P1 and P2. So this is S of P2 f alpha minus A to C f d alpha minus C to B f of d alpha. Now we have to take this SP1 alpha with A to C because this P1 is a partition for A to C closed interval. So this is S of P1 f alpha minus A to C f of d alpha. This plus S of P2 f alpha minus C to B f of d alpha. Mod. So this is less than equal to, it is a property, this mode is less than equal to mod of sp1f alpha minus this integral plus mod of sp2f alpha minus this integral, and this is strictly less than, this is less than epsilon by 2 plus this is also less than epsilon by 2 from the results, and this is equal to epsilon, but epsilon was arbitrary, so this complete mode is strictly less than epsilon. So but epsilon was arbitrary, so this f is Riemann integral on closed interval ab, and integration of this f d alpha is equal to whole this thing a, right? Thank you.